In this short webinar, I will show you how to test an overcurrent relay manually and automatically using the Mentor 12 and the Roots software by EuroSMC. This is the Mentor 12 relay tester with the three-phase current cables in red color to the relay. The trip signal blue cables coming from the relay to a binary input, and the Ethernet cable connecting the Mentor to our local area network. My computer is connected to the local area network too, so I can control the Mentor from it. Next to it, you can see the relay that we will be testing and a small webcam pointing to the activity LEDs so that you can see them at all times during the exercises. I will place now this camera in front of the Mentor screen so that you can see my interactions with it and the changes taking place in real time during the testing. Now I will replicate this screen on my computer so that you can see it more clearly there. This replication is active, so I can effectively control the Mentor using the mouse and keyboard in my computer, as you will see shortly. We will start with manual testing. Manual testing basically consists of adjusting a test current, starting the injection, and writing down the measured time when the relay trips. This relay is set to the current time characteristic that you can see here. Up to 1 ampere, the relay should not trip. For larger current values, the relay should trip progressively faster. And when the current exceeds 10 ampere, it should trip immediately. Therefore, 10 amps is what I call the short circuit boundary. This area here. I will start the testing with 1 ampere and continue with a few more current values in the overload zone. The overload zone is this here where the tripping time is progressively shorter as long as the current grows. And then I will use points beyond the short circuit boundary, these points here, which are represented here in the data grid. So I will adjust 1 ampere here now. I will do it on the screen physically, so you can see it. The changes will also be reflected on the replicated screen. They will adjust here 1 ampere and activate the app. Okay, you can see here in the small camera, okay, that the pickup LED has become active in the relay. The other LEDs are active from my previous session, so I will deactivate them now. Okay, now you have a pickup situation, which means that the relay is detecting the pickup value, the setting it has, which is 1 ampere. You can also see the chronometer on the Mentor here, running since the time I pressed the on button when I started the injection. The relay will not trip with 1 ampere because this is the setting for nominal current in this relay. So the chronometer will continue counting indefinitely. So we stop the test and reset the chronometer. In my data sheet, where I collect all the information from this test, I will write no trip. Okay, we'll use this data grid as I could use a piece of paper or an Excel file, for example. Okay, so I write no trip as a result for the testing at 1 ampere. From now on, I will be operating on the virtual console. Of course, every change that I do on the virtual console will be reflected on the physical screen in the Mentor here in this camera. Okay. So we go for the next test point, which is 1.8 ampere now. So we adjust here 1.8. You may want to keep an eye on the relay activity LEDs here. When I start the testing, this pickup LED should beat. So I start the injection of 1.8 ampere. You see the chronometer running. Okay. So as you can see, the relay has detected the trip and sent a signal to the Mentor, which has stopped the test and the chronometer. The chronometer stopped at 3.39 seconds, so we note it on our test form 2. According to my data grid, this is a valid time because it falls right between the minimum and maximum accepted trip times that you can read on the left. You can read here. Okay, so I can safely write here pass. And go to the next point, which is 2.5 ampere. Adjust 2.5 ampere here. And start. When I start, you will see that the chronometer will restart from 0. And also that the pickup LED in this camera here will start lighting again. I will now reset the other 2 LEDs which are engaged, okay? Just notifying a previous activity. Okay, so we start the test now. Now we have a trip at 1.8, which I also note on the grid. 1.8. I will show you the completed grid to you later. Okay, 1.8, which also falls in the accepted range, but we will assess it later when we have all the grid showing in front of you. So we continue with the next point. 4.0 ampere. We increase the value to 4.0. Okay, I will reset the LEDs on the relay as well and start the test. Okay, now we have a much faster trip at 0.92. I will note it down here and go to the next point, which is 6 ampere. I go for 6 ampere and start. Now we get a time of 0.56, which I write down here. Next point is 9.5 ampere. I forgot to reset the LEDs for you. I will do it now. So 9.5 ampere and start. Much faster trip at 0.34 seconds. So 341 milliseconds. Okay, 0.34 seconds. Let's write it down. I am writing the results on the background. You cannot see it now because I don't want to be switching the screen all the time. Okay, but I will show you the complete grid at the end. So the last two test points are 10.5 ampere. I will reset the LEDs on the relay now and start the test. So we only have 41 milliseconds, which we write down on our grid. Next point and last point in the test sequence is 15 ampere. Okay, we reset the LEDs on the relay and start the test. So I look at the time, 33 milliseconds now. So let's write down 33, and now I'm going to show you the completed grid. Let's write down here 0.033. Okay, and now it's time that we do some evaluating the results on the rightmost column on this grid. And you can see that all the trip times obtained during the test sequence fall well inside the margins. So all of them are pass. And these are basically the steps to manual relay testing. You can make a report with your grid or include it as a part of a more comprehensive report, adding recalculated values, other information about other relays in the installation, etc. Okay, no questions, so we continue with the automatic testing. Automatic testing consists basically on preparing software with some data, connecting the computer to the test set, and running the software. Once you have made the proper connections, you shouldn't need to operate the test set. It will act as an interface between the relay and the computer. For each test point in our characteristic curve, the software will command the Mentor to inject the test current and will capture the measured trip time. The control screen in the Mentor will reflect all changes generated by the software and all the activity detected in the relay, so it will provide you with a visual feedback of the entire test process. So what you can see here now on the screen, on the leftmost corner of the screen, is Roots. Roots is our test automation software. What you can see now in Roots is my library with a series of predefined relays. This is a very small image. I can unfortunately increase the size much more because there is plenty of information here. But the most important thing is that the first relay in the list, this relay here, is the relay that we have on the table. I have added this relay to the library with the characteristic curve that is currently active on it, the same curve that we have been testing manually. Roots includes a vast choice of protection characteristics that you can choose from, or you can build your own characteristics from scratch using formulas or discrete data. The click sequence test resembles the manual testing that we have done so far. You can see here the same curve that we have been using and the same selection of test points reflected. You can enter the test points here And routes will automatically display the corresponding trip time according to the characteristic chosen. Okay, so you can see here exactly the same results boundaries, the same tolerance, the minimum and maximum trip time allowed for each test point. Every test points 1, 2, 3, 4, and so forth, are also reflected on the screen with small circles. Now I need to activate the remote control via Ethernet on the Mentor, and also need to tell routes to connect to this Mentor across the LAN. Remote control, I select Ethernet and open the communication. So now the Mentor is ready for remote control. And in routes, I need to go to Tools, Hardware Configuration. So now I show you auto discovery, okay, and the routes will automatically search the network for a mentor, and it has found one, my mentor. It will confirm that this is the mentor I want to check, I want to use, by giving me the serial number and the IP address. So I confirm and accept. Now you test all points in sequence by clicking on Start. And you will be seeing the pickup LED activity here on this camera. Okay, we have a pickup and a trip. You see that the results of each test are automatically recorded and displayed on the rightmost column on the test point grid, exactly as we did in our grid during the manual testing. On the right, you can see here some points that fall out of the theoretical curve, which is the 0 line here, but it's normal. Okay, we must accept that no relay can trip in 0 time, even though the theoretical curve dictates that the delay should be 0. Anyway, as the tolerances are big enough in the relay definition, this has been assessed by routes as a successful trip. You can see it here. I can even look at the assessment, and I can see that the automatic assessment of this test is successful. The automatic assessment in routes tests will only be successful if all and every one of the test points have provided a good result. Otherwise, it will show failed. What we can do next is to obtain a complete report with the details of the testing. So we just click on View Report down here, generated by the report writer on routes. You will see a lot of pages. You can format your report to contain less pages with less details anyway, and you can export it to a Office format like Excel and so on. So we have some relay data here with the installation conditions. And finally, we have the test characteristic that we have used. Followed by the test grid with all the results. Okay, with the points as they have been found during the test, and in green color, which means that all those points are valid results. All tests are historically and automatically saved alongside with each relay in the routes database. You can recall any set of results at any time in the future unless you intentionally erase it from the database. Okay, so this is the end of automatic testing as well. So thanks very much for attending. Josinel, thank you very much for your assistance with the screen display. And we hope to see you next in the future sessions that we will invite you, for sure. Goodbye then.